Recall that in a discrete setting, the expectation of a function describes its average value. The formula is given here. You add up every value in your sample space. You take the value of the function times the probability of achieving it. An example that was used earlier was that you could imagine that you're gambling. Your bets pay certain values on different outcomes, and the expected value of your payout will be your average payout. Doesn't mean you'll achieve that, but it at least tells you whether this game is set up in such a way that you're likely to lose money or not. In the continuous setting, sums turn into integrals. So the expected value of gy is the same formula, but with an integral over the real numbers, and with the discrete PDF replaced by the continuous PDF. So let's consider an example here. The PDF will just be 2y between 0 and 1, keeping in mind the PDF is defined everywhere, but it is 0 at all other values. And a function that I want to average will be 2 plus y. The expected value of the function is given by the definition. We integrate from minus infinity to infinity, which raises a problem because the PDF was only defined from 0 to 1, but it wasn't. Remember that outside of that interval, it's 0. It is important to keep reminding yourself of this, though, because a very common mistake that students make when they're computing expected values of a variable or a function is that they use that same PDF everywhere. Actually, this PDF has 3 parts. It is 0 outside of the region it was given, and it is 2y between 0 and 1. So turning this into our integral, from negative infinity to 0, I have my function times 0. The blue region that's interesting, I have my function times the PDF 2y, and then again 0. The zeros go away. That term inside that middle integral may throw you for a loop. If you try to do integration by parts, you will get the right answer, but it will be very hard. When you multiply polynomials, the correct way to integrate is to expand the product first. So multiplying this out, there's 4y, there's 2y squared. And now I can integrate it term by term. So the 4y will integrate to 2y squared. The 2y squared will integrate to 2y cubed over 3. Then substitute in your limits, and you get an answer 8/3. That's not in the standard range where probabilities must be between 0 and 1, but that's fine. This is not a probability problem. This is an expected value or average problem. Let's turn our attention to a slightly harder example. The PDF in this case has 2 parts that are defined, and there are 3 parts that weren't mentioned. To integrate over that entire region, it's helpful to draw out a number line. Mark the PDF where it's 0 and where it's non-zero, and then integrate over all of them. So on the left, the red parts I put all correspond to zeros. By the way, those parts that correspond to zeros can be dropped. Then the blue part, we have a negative y and a 1/2. As was discussed before, the correct way to integrate a product is to expand it first. So minus 2y and minus y squared. Then each piece can be integrated. And these are standard polynomial integrals. Finally, substitute in the top and the bottom limits. Do some arithmetic. and we have an answer.